Alright, so let's start by reviewing. The solution to linear system is most often an ordered pair. There are some special circumstances, but we'll learn about those in another lesson. We find this ordered pair at the point of intersection, where the two lines cross. And we check to see that we have that right point, that we didn't make any mistakes, by plugging or substituting the value for the variables back in. So plugging the numbers back into the equations. And remember both of them. So in this lesson we're going to learn how to solve systems by substitution. And it's exactly like it sounds like. We are going to be substituting back in an expression into a different equation. So for this first example I thought we would do an application problem. A family of 5 went out to a football game. Tickets for the game were $12.50 for people 12 and under and $15 for people over 12. The total admission was $72.50. And these are the two equations that represent that situation. And the question is, how many people were over 12? So let's start with our let statement. Let x be and let y be. So the equations are given to you this time. Eventually you're going to be writing your own equations, but for this one I gave them to you. X plus y equals 5. Well, there were 5 people in the family, and we're looking for the number of tickets, so I'm going to have let x be the number of tickets for those 12 and under, and let y be the number of tickets over 12. And we could solve by graphing like yesterday, but with these decimals in here, it will not be as nice. So we're going to solve this one by substitution. Alright, I suggest at this point for you to stop the video and just take a moment to write these steps in your notes. So that way you're not trying to listen and do the work and write the steps all at the same time. Alright, so the first step is to solve one of the equations for one of the variables. This is a really important part of the process because if you make a wrong move here, if you make an unwise choice on which variable you're going to solve for and which equation you're going to use, you're going to make your life way difficult. So here, I know that I will not be using this one because we have to solve for one of the variables, that literal expression type of thing. And these have coefficients, so it's going to be really ugly. This one, on the other hand, has both the x and the y don't have coefficients other than 1, so it'd be really easy to solve for either this x or this y. So I'm going to choose to solve for the y. So I'm going to subtract x from both sides. So y equals 5 minus x. So that first step done. Second step, substitute this expression, and by this expression I'm talking about the one that we just wrote, this expression into the other equation and solve for the other variable. So I'm taking this expression and I'm putting it in for y because I know y equals 5 minus x. So that gives me 12.5x plus 15 times, I'm going to put this expression in there, and that's going to equal 72.50. So this expression is dropped in place of the y. And from here it's just, oops, I put a y there and it was supposed to be an x. From here it is just solving an equation for x. So first I have to do the distributive property. So 12.5x plus 75 minus 15x equals 72.50. I can combine my like terms. So negative 2.5x plus 75 equals 72.50. I am going to subtract my 75. It's negative 2.5x equals negative 2.5, and divide. So now I can see that x equals 1. But we're not done with this yet. This tells me, remember I let my x be the number of tickets that were 12 and under, and I need the number of tickets that were purchased for people over 12. So I have to plug this number, so I'm going to substitute this value that I just got back into the first equation up here and solve. So I know y equals 4 minus 1, so y is, I said 4. 5 minus 1, so y is 4. Now we learned yesterday that a solution to a system is an ordered pair that makes all of them true. So this is the solution to the system, but it doesn't answer the question. The question asked how many tickets were over 12. So there's 4 tickets purchased for over 12. So this is my answer because it was an application problem. This is the solution to the system. And the last step, I'm kind of out of room, is checking. Check this solution. So just like yesterday, if this is true, you could plug the 1 in for x, the 4 in for y, to make a true statement in both of them. So I'm going to do that up here. 1 plus 4 does equal 5. That checks out. And 12.5 times 1 plus 15 times 4 does equal 7250. So both check out, so I know that is my answer. All right, let's look at another example. Remember, the first thing I have to do is solve one of the equations for one of the variables. So I'm going to look. I have a 7x, a 3y, a 2x, and a y. So if I chose one of these three, it would be more complicated and I'd be left with fractions. So I'm going to choose this y to solve for because it doesn't have a coefficient other than 1, or in this case, negative 1. So I'm going to subtract 2x from both sides. That leaves negative y equals negative 2x minus 10. And then, of course, I have to switch all of the signs, like I'm multiplying everything by a negative 1. Step 2, substitute this expression, the one we just wrote, into the other equation, so this first equation for the variable. So instead of y right here, I'm going to write 2x plus 10 because I know y equals 2x plus 10. So this is what it's going to look like. So this is step 2. 7x plus 3, and I'm going to leave space for that expression, equals 43. So I'm going to take this expression and put it in here, 2x plus 10. And from here, it's just solving. So 7x plus 6x plus 30 equals 43. So 13x plus 30 equals 43, and solve from there. So coincidentally, my x is 1 again. So I'm going to put that over here in the ordered pair. So I substituted that in and solved for the other variable, so I've done the first two. Now I'm going to substitute this value, what we just got, for x and plug it back into that first equation. So y equals 2 times 1 plus 10. Y equals 12. Again, I'm using the equation that I wrote to solve for y because I know I'm going to check my work by plugging it back into both. So this is my check step. So 7 times 1 plus 3 times 12 is 43. 36 plus 7 is 43. And so I'll check it in the second equation. 2 times 1 minus 12 is a negative 10. So both check out, so I know this is my solution. Because it was not an application problem, the solution is going to be that whole ordered pair. All right, let's try one more example. Let's try to fit in one more example for those of you that need it. So our first step is to solve one of the equations for one of the variables. So this is where I have to make a wise decision. Looking at them, this x right here is the only one with a coefficient that is 1, so this is the one I'm going to solve for. So I'm going to subtract 5y from both sides. So now I have x equals 17 minus 5y. The next step, substitute this expression, the expression we just wrote, in for that variable. So now this is x, so I'm going to put it in for x. The last example I was putting it in for y, but I solved for x this time. So it is going to look like negative 3 times 17 minus 5y plus 2y equals 0. So 51, a negative 51 plus 15y plus 2y equals 0, because I did the distributive property. Now I can combine my like terms. Negative 51 plus 17y equals 0, and I'll solve from there. So 17y equals 51, so y is 3, because I divided both sides by 17. So I'm going to put this up over here. It's my y this time though, so I have to make sure I put it in the second, for the second number in the ordered pair. Then I'm going to do my next step, substitute this 3 in for y here, and solve for x. So I think I'll use red. So x equals 17 minus 5 times 3. So 17 minus 15, x is 2. And then I would really like you to get in the habit of checking your work. So make sure that you plug in the 2 for x, negative 3 times 2 plus 2 times 3. So negative 6 plus 6 does indeed equal 0. And 2 plus 5 times 3 does indeed equal 17. So they both check out, so I know that this is my answer.